Today we are going to solve maths questions from JEE Mains 2013. I have selected a few questions at random to solve today. So let's begin with the first question. Let A and B two sets containing 2 elements and 4 elements respectively. The number of subsets of A cross B having 3 or more elements is. So first let's try to figure out the number of subsets of A cross B. So we know that number of elements in A is 2, number of elements in B is 4. So number of elements in A cross B is number of elements in A times the number of elements in B, which is 2 times 4, which is 8. So we have 8 elements in A cross B. Now we need to find subsets that have 3 or more elements. So to find the total number of subsets, we can have 8C0, which means that the subset has exactly 0 elements. We add 8C1, which means that the subset has 1 element, and so on we go until the subset has 8 elements. A more important or more useful way of solving this is, we know that we have 8 elements, and now each element has 2 choices. Either to be a part of the subset, which means it's in a part of a subset, yes, or not in a part of a subset. So we have 2 choices and we have 8 elements. So the total number of subsets are 2 to the power 8, which is 256. And if we add these terms together, we will also get 256. But calculating and adding these terms is a headache. This is a simpler way of finding the total number of subsets. Now we can subtract the subsets having 0 element, subsets having 1 element, or subsets having 2 elements to find total number of subsets having 3 or more elements. So which leaves us with 256 minus 8C0, which means subsets having 0 element. We subtract 8C1, which is subsets having exactly 1 element, and we subtract 8C2, which means subsets having exactly 2 elements. So 8C0 is 1, 8C1 is 8, and 8C2 is 28. And on solving we get 219. So the solution for this is, there are exactly 219 number of subsets of A cross B having 3 or more elements. Let's move on to the next question. The real number k for which the equation 2x cube plus 3x plus k equals to 0 has 2 distinct real roots in 0, 1. So we have a function fx which is 2x cube plus 3x plus k equals 0. And we need to find 2 distinct real roots in 0, 1. So we cannot find the roots of this function without knowing the value of this term k. So let's try to get some other useful information. So the derivative of this function will be 6x squared plus 3. For a fact, we know that x squared is always greater than equal to 0, which gives us 6x squared is always greater than equal to 0, which also means that 6x squared plus 3 is greater than 0. To give a hard bound, we can say that 6x squared plus 3 is greater than or equal to 3, but that is not a useful information. So from this, we can say that the function is strictly increasing function. When the derivative of a function is always greater than 0, it is strictly increasing. And we know that for a strictly increasing function, there can only exist one real root. So if we were to show it in a plane, a strictly increasing function looks something like this or something like this. And a function of this kind can have at most one real root. It cannot have more than one real root. So we know that a strictly increasing function, for a strictly increasing function, at most one real root. So there is no value of k for which this function can have 2 distinct roots. Let's move on to the next question. So here we need to solve the limit of a given trigonometric function. So let's get some trigonometric identities to solve this. So we know that 1 minus cosine of 2x is 2 sine square x. And we know that limit x approaching 0, sin x over x is 1. We also know that limit x approaching 0, tan x over x is also 1. So we need to use these two information to solve our limit. So let's simplify the function that we have. So we know that 1 minus cosine 2x is 2 times sine squared x times 3 plus cosine x over x times tan 4x. So now we can multiply and divide by x squared so that the term sine squared x over x squared becomes 1. We can also multiply and multiply and divide by 4x so that the term tan 4x over 4x becomes 1. So let's write it in a better way. So this gives 2 sine squared x over x squared times 3 plus cosine x times we have x squared remaining in the numerator, and we have x and 4x, which gives 4x squared remaining in the denominator as well, times 1 over tan 4x over 4x. And now we can plug in the limit x approaching 0 to get the values. So which gives 2 and sine x square over x squared is 1 times 3 plus cosine x. So 3 plus cosine x is, cosine 0 is 1, so 3 plus 1 is 4 times we have x squared over 4x squared, which is 1 over 4 times 1 over tan 4x over 4x. So we know that for this limit is 1, so which means 1, and this gives us 2. So the limit of this trigonometric function when x goes to 0 is 2. Let's move to the next question. The equation of the circle passing through the foci of the ellipse x squared over 16 plus y squared over 9 equals 1 and having a center at 0, 3 is. So we know that the equation of an ellipse looks like x squared plus a over a squared plus y squared over b squared equals 1, where if a is greater than b, then it is a horizontal ellipse. Here we know that the value of a is 4 and the value of b is 3. So this is a horizontal ellipse. And we know that for a horizontal ellipse, the foci is plus minus AE comma 0, where E is the eccentricity of the ellipse. And we can calculate E, that is under root 1 minus b squared over a squared. So which gives us a value of under root 7 by 4. And we multiply this by our A, which is 4. So the foci we get is plus minus under root 7, 0. So let's draw a rough image of what the ellipse should look like. So the ellipse should look something like this, where the two foci are here. So this is the under root 7, 0, and this is the under root 7. So this is the minus under root 7, 0 foci, and this is the plus under root 7, 0 foci. And we know that the center of the circle is 0, 3. So to find the equation of the circle, we need two things. We need the center and the radius. So the center is already given in the question, 0, 3. We need to find the radius. And we know that the circle passes through these two foci of the ellipse. So if we find the distance of this line segment, then that is the radius. So the distance of that is under root 7 minus 0 square plus 0 minus 3 squared, which gives under root 7 plus 9, which is under root 16, which is 4. So the radius of the circle is 4. Which gives us that equation of the circle should be x minus h squared plus y minus k squared equals to radius squared, where the center is h comma k and radius is r. So this says x minus 0 squared plus y minus 3 squared equals to 16. If we simplify this, it gives us x squared plus y squared minus 6y plus 9 equals 16, and which gives x squared plus y squared minus 6y minus 7 equals 0. So this is our answer, x squared plus y squared minus 6y minus 7 equals 0. Let's move on to the next question. A multiple choice examination has 5 questions. Each question has 3 alternative answers, of which exactly one is correct. The probability that a student will get 4 or more correct answers just by guessing is. So, a question has 3 choice and one of them is exactly correct. So, the probability of one option being correct is exactly 1 by 3. So there is a 1 by 3rd probability that option A is correct, 1 by 3rd probability that B is correct, and 1 by 3 probability that option C is correct. So the probability of getting a correct answer is 1 by 3, and the probability of getting a wrong answer is 2 by 3. Now, there are exactly 2 ways in which the student can get 4 or more correct answers. So the one way is he gets 4 correct and 1 wrong, and the other way is he gets all 5 correct and no wrong. If we add the values of these two, that is our answer. So to get 4 correct answers, he needs to guess them correctly, which gives 1 over 3 to the power 4, and he needs to have 1 wrong answer, which means a probability of 2 by 3. And to get 4 correct answers, there are a total of 5C4 ways. So if we have 5 questions, he can either get the first 4 correct, or the last 4 correct, or the last 3 and the first question. This way he has like 5C4 ways of getting 4 correct answers. And to get 5 correct answers, there is only one way to get all 5 correct, which can also be written as 5C5. And he gets all correct, which means 1 by 3 to the power 5. And if we solve this, we get 5 times 2 over 3 to the power 5 plus 1 over 3 to the power 5, which gives us 11 over 3 to the power 5. So option 3 is the correct answer. Let's move on to the next question. The area in square units bounded by the curves y equals to under root x, 2y minus x plus 3 equals to 0, x-axis and lying in the first quadrant is. So first let's try to get the line in the standard format of y equals to mx plus c. So we have 2y equals to x minus 3, y is x over 2 minus 3 over 2. So we know that the slope of the line is half and the y-intercept is minus 3 by 2. Let's try to show this in a graph. So the parabola looks like this, y equals to under root x, and our line looks something like this, where the y-intercept is minus 3 over 2. And the x-intercept is evident from the equation, should be 3. So now we need to find the area between these two curves and the x-axis, which means this shaded area. We need to find the area of this shaded region. So for that, we need to find this intersecting point, and this can be our upper bound, and this, the lower bound over here, would be 0. So to find this, we need to equate the equations. So we know that the parabola is this, y equals to under root x, which means x equals to y squared, and from the line we have x equals to 2y plus 3. So y squared equals to 2y plus 3, y squared minus 2y minus 3 equals 0. We can factor this out as y minus 3 times y plus 1 equals to 0. So we have y equals to minus 1 and 3. So y equals to minus 1 is not useful for us, so we'll only use y equals to 3, which is the upper bound. So our integral would be from 0 to 3 fx minus gx dx, where fx is the line and gx is our parabola. So if we plug in these values, we get 2y plus 3 minus y squared dy, and that is y squared plus 3y minus y cube over 3, and we have the limits from 0 to 3. Plugging in these, we get 9 plus 9 minus 9, and when we plug in 0, we get all zeros, and on solving this we get 9. So our answer for this one is the first option, 9. Let's move on to the next question. If the lines x minus 2 over 1 equals to y minus 3 over 1 equals to z minus 4 over minus k, and x minus 1 over k equals to y minus 4 over 2 equals to z minus 5 over 1 are coplanar, then k can have. So the standard equation of line goes x minus a1 over c1 equals to y minus a2 over c2 equals to z minus a3 over c3, and the other line can be written as x minus b1 over d1 equals to y minus b2 over d2 equals to z minus b3 over d3. And if these two lines are coplanar, it means that they lie on the same plane, which means a1 minus b1, a2 minus b2, a3 minus b3, c1, c2, c3, d1, d2, d3. The determinant of this should be 0. And from the equation of the line, we know the values of a1, b1, a2, b2, a3, b3, c1, c2, c3, and d1, d2, d3. So plugging in, we get 1, minus 1, minus 1. So a1 is 2 and b1 is 1. So 2 minus 1 is 1, and similarly we get minus 1 for a2 minus b2 and minus 1 for a3 minus b3. The values of c1, c2, and c3 are 1, 1 minus k respectively, and the values of d1, d2, d3 are k, 2, and 1. So the determinant of this should equal 0. And on finding the value of the determinant, we get 1 times 1 plus 2k plus 1 plus k squared minus 2 minus k equals to 0, which means that k squared plus 2k plus k equals 0, which means k squared plus 3k equals 0. So we have k equals to 0 and minus 3. We get exactly two values. So our answer would be option 3, exactly two values. Let's move on to the next question. The distance between two parallel planes 2x plus y plus 2z plus 4x plus 2y plus 4z plus 5 equal to. So since these two planes are parallel, so equation of a plane is ax plus by plus cz plus d equals 0. So this is 2x plus y plus 2z equals 8. So for parallel planes, the terms a, b and c should be multiples of each other. So the second equation can be divided by 2 to get the same values. So we get, when we divide the second equation by 2, we get 2x plus y plus 4z plus 2z equals to minus 5 over 2. So we have two equations with exactly same value of a, b and c and different values of d, and we need to find the distance between these two planes, and we know that that is minus 8 minus 5 over 2 over under root, we have a square plus b square plus c square, which is 2 square plus 1 square plus 2 square. So this leaves us with 7 over 2. So the correct answer for this is option 3, 7 by 2. So that's it from me today. If you have any other questions or clarifications, please feel free to comment below or email me.